Welcome back. This is the lecture that goes with assignment 2 from your homework. And this finishes up our very quick review of pre-calculus. So to begin with, we want to talk about parametric equations and how they are used. And, rather than go into a complete description of them, I'll simply remind you that you need to use your Inspire in order to graph parametric equations and to find the inverse. So this is information that you can easily get on your own. As just a quick example of parametric equations, you might want to think about the ones where given by x is equal to 2 times the cos of t and y is equal to 3 times the sine of t. Should be able to graph this on your Inspire. Notice that there is, because t goes from 0 to 2 pi, there is a beginning and an end and a direction implied in that graph. You should also be able to algebraically show that this equation is equivalent to this. And therefore, its shape should be an ellipse. So I spoke a little bit about the idea of the inverse of a function. And this is an important idea and one that you need to think about a little bit. For example, if we talk about the function f of x is equal to 2 times x minus 3 cubed plus 5, and we want to write the inverse, one of the things that is helpful is if we think about f as consisting of the operations first subtract 3, then cube, then multiply by 2, and then add 5. The inverse function is going to work in the opposite order in the opposite operation. So it's first going to subtract 5, and then divide by 2, and then it'll take the cube root, and finally it will add 3. So therefore, the inverse function will be written as x minus 5 divided by 2 cube root plus 3. That's pretty cool the way that works. So if we continue, we see that the inverse of a function will itself be a function only if the original function is 1-to-1, and that can be seen visually if f passes the horizontal line test. Similarly, we can look at the conditions under which we can write the inverse of a parametric equation. For example, if we have x is equal to f of t and y is equal to g of t, then the inverse will be written as y is equal to f of t and x is equal to g of t, which is a pretty simple way to do it. And this is also a very easy way to graph the inverse. If you're in parametric mode, just switch the values for x and y. Let's talk a little bit more about logarithms. There are a couple of important properties of logs that need to be stated and understood. One of them is that if I take b and raise it to the log base b of x, I'm going to get x. And that's the same thing as saying log base b of b to the x. Both of those expressions reduce to simply x. We also want to understand that the change of base formula works like this. If I have the log base b of t, that can be written in terms of the natural logarithm as ln of t over ln of b. And really there's nothing at all special about the base here. It might as well just have been log base 3 or log base 7 or log base anything. And finally, in our review, let's talk again about trig functions. Some of the key terms to make sure we understand or what it means to be periodic, what the amplitude is, and finally what it means to be even and odd. And that certainly translates to any type of function, but in particular we're looking at what it means for a trig function to be even and odd. The best example of a trig function which is even is cosine, and for an odd function is sine. When we look at the inverse trig functions, arcsine, arccos, arctan, the most important feature of them is to understand what the range of each is. And so for arcsine, we're minus pi over 2 to pi over 2. For arccosine, we're 0 to pi. And for arctan, minus pi over 2 to pi over 2, exclusive of the endpoints. And so finally, I like to finish my discussion of trig with what I call my favorite trig question. And this is a question that, in my opinion, reveals just how well a student understands what trig is all about. And the question is simply this: what is the arcsine of the sine of 2? I'll leave the answer hanging, but I will say this. We all know that arcsine and sine are inverse functions, and so the obvious answer to this would be, oh, the answer must be 2. Well, if you think back to the previous page, we talked about the range of arcsine being minus pi over 2 to pi over 2, and 2 is not in that range. And so this requires a little bit of thinking, and I'll just give a little bit of work here. Here is a unit circle, and here is where 2 is, and I'll leave it to you to finish this work. See you the next time.